Hi, in this video of Inkpot, we are trying to understand how to find out the point of consumer equilibrium. In this video, we're going to set the general process which we're going to apply in the later videos when we do a variety of different kinds of equations, different kind of utility functions. But in this video, we're going to set the basics, and these basics will then be applied to a variety of other questions. A consumer equilibrium is the point which a consumer buys, which is a combination of budget lines and preferences, which we have studied independently before, but now we combine the two together to find out the point which a consumer buys. So what are the various places of equilibrium in a very general way of speaking? We can have a consumer equilibrium in the interior, which is if we have a budget line, a downward sloping budget line, then a consumer never consumes inside the budget line. Like we've said before, he will only consume on the budget line, right? Interior optimum implies that he will consume anywhere within this budget line. He will not consume at either point A or point B, which is the point of the two axes, but he will consume anywhere on the inside of the budget line. This can be either at tangency or at kink. Mind you, I'm stating this here that you cannot have equilibrium other than these two conditions at any other point in the interior. So whenever you feel you see a utility function which has an interior optimum, then that interior optimum you can get either from the tangency condition or from the kink condition. The second place for us to have an equilibrium is the corner equilibrium, which is these two corner points, the corner points on the y-axis or the x-axis. So corner is either the x-axis or the y-axis, so either point A or B on the budget line, right? On the budget line. And a consumer always consumes the point whichever gives him a higher satisfaction, right? So let's try and do some of the questions to understand better. Consumer equilibrium is the highest satisfaction bundle that is affordable to the consumer. We always have to say diagrammatically first. So you may see a few functions sometimes which you may feel that you already know the answer to. But before jumping to the conclusion, you always need to see it diagrammatically, right? So whenever you need to figure out where the equilibrium is lying, you draw a rough sketch. In the rough sketch, you draw the budget line, you draw the general shape of the IC, whichever function it is. So if it's a convex function, then you draw multiple convex functions. If it's a concave function, you draw multiple concave functions, and you figure out where the diagram is pointing out the equilibrium to lie. We're going to study only this process in this video. So for example, the first example we are taking is a normal convex IC. So this normal convex IC could be a Cobb-Douglas or could be any convex IC. So whenever you draw multiple convex ICs, you see this point is the point of equilibrium. Let's call it E0. Let's deliberate on this. Let's see why E0 is the point of equilibrium. We'll just take 2 minutes on this. You see, a person wants to go on a highest IC possible. Now I'm assuming these ICs are going outward like this. That means the higher up I go, the more utility I get, which means technically a consumer would want to go to the highest possible IC, so he should go to this IC. Although we can draw a million more and just keep on going, but then from the whatever we have drawn, this is the highest possible IC. But he can't afford this IC, which is why he gets stuck to the highest possible point, which is affordable, which is E0. Why wouldn't he hypothetically buy another point called E1? Because E1, although is affordable, is on the budget line, but is lying on a lower IC, which is why in this scenario, we have an interior optimum. We are neither lying on the A or the B, we are lying inside. Secondly, the condition of the equilibrium is tangency. So how do I figure it out numerically? Numerically, I'll apply the tangency condition, which is nothing but MRS is equal to P1 by P2. I want to point out a small thing here. MRS is always positive. So you always take P1 by P2 also to be positive. So you don't take the minus sign, you don't take slope. You take MRS to be equal to P1 by P2 to figure out the numerical of this. Let's look at another example. So let's suppose now again, this is my budget line. Red one is my budget line, let's say AB. And my ICs are now straight lines, which means these are the ICs of perfect substitutes. These are the ICs of perfect substitutes. So whenever I have perfect substitutes, I will have a corner equilibrium. So it can be either this corner or this corner. How do I figure out which corner gives me a higher satisfaction? So although for perfect substitutes, we will apply a general condition later on, but here in diagrammatically speaking, how do I know which point is better? Again, you apply the same logic. You go to the highest affordable bundle. The bundle which is affordable and yet gives you the highest satisfaction, that is the bundle you buy. So although the person could be consuming this point A, it's lying on a lower IC. He could be consuming at this point, it's still lying on a lower IC. When you compare it to this point, which is the highest possible IC that a person can consume. So therefore this becomes my equilibrium, which is E naught. Right? I hope this process is clear, but let's still take one more example. So the other example we are taking is an example of a good and a bad. Now logically, a person never spends money on a good which doesn't give him satisfaction. A person never spends any money on a good which doesn't give him satisfaction, which means he will never spend money on a bad and he will never spend money on a neutral. So if you have a good and a bad combination, a person will always consume the good and he will never consume the bad, right? So if you look at this diagram, now tell me where the equilibrium might lie. Now you could always draw another IC here because as we said, the ICs are unlimited. So we could always draw this one more IC, the blue one, which is parallel to all the ICs which have been drawn before. Now how do I know whether I'm consuming at A or am I consuming at B? This depends upon where the good is. So if you have the good to be here, then you're consuming at a B. And if the good was not here, but the good was here, then you would be consuming at a A, right? So whichever point gives me higher satisfaction. So if my arrows are pointing this way, then the highest possible IC I have is this one, so it's B. But if the arrows were pointing the other way, then the highest possible point I have is A, so A becomes the equilibrium. We're going to apply this general analysis to a variety of other examples in the other videos, but this is your very, very basic on consumer equilibrium.